When you look at images of our planet from space, you just see this incredible silent beauty, right? A swirl of clouds, the deep blue of the oceans, that patchwork of green and brown land. It really is a breathtaking portrait of home. And for decades, satellites like Landsat and Sentinel have been our tireless eyes in the sky. They're orbiting hundreds of kilometers above us, constantly capturing these stunning views, creating this permanent record of our world. But here's the thing. These images are so much more than just pretty pictures. They are dense, layered collections of data. So what happens if we start to zoom in? What if we challenge our whole perspective on this vast landscape? What if we zoom in so far that the familiar shapes of continents and coastlines just dissolve into a single abstract square of color? This is a pixel. And on its own, it looks like, well, nothing. But locked inside this tiny block is an entire story about our planet. Okay, let's dive into this. To unlock that story, first we have to understand the language it's written in, and that language is light. So get this. Every single thing on the Earth's surface interacts with sunlight in its own unique way. You can think of it like a fingerprint. Healthy green plants, dry soil, a deep lake, they all reflect and absorb different wavelengths of light. Scientists call this a spectral signature, and it's the fundamental clue that satellites are looking for. Now, what's really fascinating here is it shows us just how limited our own senses are. We only see this tiny sliver of visible light. But satellites, they're designed to see far beyond that, into parts of the electromagnetic spectrum that we can't, like the near-infrared, or NIR. And this is where the real magic happens. So the crucial point is how different materials react to this invisible light. Just look at this. Healthy plants, which reflect green light to our eyes, reflect near-infrared light incredibly strongly. It's like they're shouting at the satellite. Meanwhile, water does the exact opposite. It just absorbs almost all near-infrared light, making it look very, very dark to a sensor. This difference, this is the secret key. Now, knowing these rules is one thing, but how do we actually use them? This is where the technology comes in. The satellite isn't just taking a photo, it's capturing data across multiple bands of light and basically acting like a decoder ring. Okay, let's see this in action. The image on the left shows what you or I would see with our own eyes, a pretty standard view of a landscape. But remember, the satellite has a secret weapon, its ability to see that near-infrared light. So what happens when we use that data? And boom, this is the big reveal. On the right, that's a false color composite. Here, the satellite's data from the near-infrared band, which is totally invisible to us, has been assigned the color red. And suddenly, all that healthy vegetation that was reflecting NIR so strongly just pops, glowing in these vibrant shades of red and pink. Water bodies become almost black. Instantly, you can distinguish a pine stand from a deciduous forest or see exactly where a field ends and a swamp begins. So now that we've cracked the code, what can we do with it? Because this isn't just a neat visual trick, it is a powerful tool for understanding our changing world, one pixel at a time. Take a look at this data from Shimla, India. By classifying pixels over time, researchers could actually quantify the increase in rock and urban land use, that's the red bar. And what happens at the exact same time? The line showing the maximum temperature trends steadily upwards. This is how we can visualize and prove the urban heat island effect. As vegetation gets replaced with concrete, the area literally gets hotter. It's a whole story told by millions of pixels. And this isn't just for academic research. As this quote highlights, this technology is now a crucial, absolutely integral tool for people who manage our natural resources, from government agencies to private companies. It's how modern conservation and planning actually gets done. And that one example is just the beginning. The applications are incredible. Farmers can monitor crop health from space. Ecologists can track the spread of an invasive shrub. Hydrologists can map changes in water bodies after a flood. We can see deforestation happening in near real time and even assess the moisture in the soil. All of this from the spectral signature of a single pixel. So let's just zoom back out for a moment. We started with a simple, beautiful picture, but now we can see it with a completely new understanding. That image of Earth is no longer just a static portrait, it's a dynamic, living diary. Each and every pixel is a data point, a tiny entry telling us about the health of a forest, the temperature of a city, or the growth of a crop. It's the story of our planet, constantly being updated, entry by entry. And that brings us to the final crucial question. We are generating this data at an unbelievable rate. So as we build more advanced AI and machine learning models to read and interpret these billions of tiny stories faster than any human ever could, what new patterns are going to emerge? What will this living diary of our planet tell us about where we're headed next?